Okay, good morning, class. So today we will discuss about Thermodynamics 1. Our professor, Engineer Francia Barrientos excuse me, from the Mechanical Engineering Department. So here's an overview for our topics. So the first module that I uploaded is this one, the history, basic principles, and terminologies in thermodynamics. Okay. So for the first one, we will start this thermodynamics. So the history of thermodynamics and how well the development of this subject as well as the real life application of thermodynamics. This is also a good foundation because we need to define the different concepts that will prevent us in possible misunderstandings in your next future subjects. So studying the basic concepts and different properties of the system, we need also to review the dimension and unit that are used here in thermodynamics because that is the basic, and also the temperature scales because we all know that the temperature scales here in thermodynamics is different from the temperature scales that we are used to in solving problems. So, and also, last but not least, the pressures that are very vital. Okay. So first, we need to know about the history of thermodynamics. So, first one, after a very long run, so this is the first start of our thermodynamics. So, the first one is that about 300 BC and to 500 BC, Egyptian and then Greek scientists speculated that heat energy was a fluid that they called phlogiston. Okay. After that, Greek scientists were debating whether a vacuum could be possible exist or be created. So vacuum, pumasok mo dito yung word ng vacuum. And also 17th, 18th centuries, meron na tayong transformation from primitive magic of alchemy to the subject thermochemistry. Okay. And 1662, pinakaunang na-publish is yung Boyle's Law natin. Okay? Kasi pinaka-importante ito lalo na sa ideal gas. In 1697, nakita natin yung construction of the first successful atmospheric steam engines in England by Thomas Savery and Thomas Newcomen. So these engines were very slow and inefficient. So, but they opened the way for the development of a new science. Okay? Also, meron din tayong first engine na na-produce. So, a steam engine was patented by James Watt. So, sa mga EE dyan, you know the word Watt. So, and also the Charles Law and the different Guy-Lussac's laws were published. And in 1824, that is the memorable history of thermodynamics wherein meron na tayong father of thermodynamics. Sino yan? Si Nicholas Leonard Sadi Carnot, wherein pinublish niya yung reflections on the motive power of fire. Also, may research din siya na present as well as well-reasoned theoretical treatment for the perfect heat engine. Okay? Kasi doon nagmula class ang thermodynamics sa Carnot cycle. So, papasok doon yung heat engine. Okay? Doon nagsimula lahat kasi may tinatawag tayong at specific temperature, ano ba yung mapoproduce ng heat? Okay? So, yun. So, with his multiple scientific contributions, including the Carnot heat engine, so Carnot theorem and the Carnot efficiency, so Nicholas Leonard Sadi Carnot is often described as the father of thermodynamics. Bakit? Kasi doon nagsimula lahat ng mga different cycles wherein madidiscuss pa sa inyo lately or in the future sa thermodynamics 2. Okay? So the basic Rankine cycle, heat regenerative, and the other gas cycles. Okay? So doon nagsimula sa Carnot cycle ang different processes and cycles natin. Okay? 1849, thermodynamics was first used in publication by Lord Kelvin. So knowing that Lord Kelvin, so papasok din dito yung temperature natin na Kelvin. Okay? Thermodynamic temperature scale, which is Kelvin. Okay? In 1850, pumasok na din dito yung first and second law of thermodynamics. So madidiscuss din tayo dito. So papasok na din yung pangalan ni William Rankine. So William Rankine, so if we have Kelvin, we also have Rankine. So Rudolf Clausius and Lord Kelvin. Okay? In 1859, the first thermodynamic book was written by William Rankine, a professor at University of Glasgow. Okay. Okay, I'll just share this. So ulitin lang natin. To sum it up, history ng thermodynamics. So ang father niya is Nicholas Leonard Sadi Carnot. Okay? Bakit? Kasi siya yung simula ng lahat. Carnot cycle, Carnot theorem, and the Carnot engine. Okay. So what really is thermodynamics? So sabi nila, it came from the Greek word thermi and dynamis. So ang thermi class, it is meaning heat, while dynamis meaning strength, particularly applied to motion. Okay? So ibig sabihin, may heat and motion. So, hindi mawawala yung heat mo dito sa processes. Okay? Ang thermodynamics class, nagdi-deal din ng energy transformation, conversion of heat into the work. So, papasok dito yung heat, work, and the production and the efficiency of a certain cycle, of a certain process, okay, of a certain engine. So, meron madami tayong energy transformation. So, papasok din dito. Sabi ko nga, it is the science that deals with the relations between heat, work, and properties of the system. Okay? So, what are the different applications? We all know physics is also in our daily life kasi nga, branch din to ng physics, thermodynamics. It is a very broad application. Okay? So, madaming application ang thermodynamics. So, makikita nyo to araw-araw. So, all type of vehicles that we use, specifically yung cars, motorcycles, trucks. So, that is sa land transportation. While ships, so ships, yacht, meron din doon class. Also in the airplanes. So, many other types of work on the basis of the second law of thermodynamics and Carnot cycle. So later, malalaman natin kung ano nga ba ang second law of thermodynamics and the Carnot cycle in the next topics. So, pwede din gumagamit sila ng petrol engine as well as diesel engine. So, pero yung law, parehas pa rin. Okay? So, these are the different enumerated application of thermodynamics. So, makikita nyo din to sa bahay nyo. So, all the refrigerators. So, heating and cooling systems. So, papasok kung dito yung refrigerators nyo. Sa bahay, makikita nyo yung air conditioning nyo. So, thermodynamics in class kasi that is where heat is transferred or heat is released. Okay? After that, naku-convert mo into cold. Diba? So, may process doon sa compressor, lalo na sa air conditioning. And also the refrigeration. And ito din, all types of air and gas compressors. So, kadalasan yung makikita to sa mga vulcanizing shop. Okay? So, itong blowers and fans, sa malls, makikita din ito. Okay, meron din tayo. Sabi ko nga, heat transfer. So, very important to between two medium. Okay? So, madami din heat exchangers, evaporators, condensers, radiators, and coolers are some applications of thermodynamics. So, sabi ko nga, ang pinaka main application ng thermodynamics is it involves the study of various power plants. So, ano nga ba? We have thermal power plants, nuclear power plants, hydroelectric power plants, and power plants on renewable sources like solar, wind, geothermal, tides, and waterways. So here in the Philippines, we have, on our previous plant tour, we go to the to Rizal, Pililla, Rizal, wherein the different wind turbines are, built. So, top siya ng mountain. I mean, some of you can go there. Kaya lang may pandemic. So, that is one of the application of thermodynamics. Wag na tayong lalayo, we have also here in the Bicol, the EDC, the Bachmann, the Energy Development Corporation located at Bacon, Manito, and also the PGPC and the Aboitiz there at the Tiwi. So that is a geothermal power plant. So, excuse me, both are thermal power plant. So, thermodynamics, yun. Class application yun ng thermodynamics na mahahanap natin dito. Specifically, sa mga power plant. So, nuclear sa Philippines, we are just establishing the nuclear power plant in Bataan. Okay? So, hindi pa. Suspended pa yung nuclear natin sa Bataan. Okay? Sabi ko nga, renewable energy is an important subject area of thermodynamics. Why? Because it involves studying the feasibility of using different types of renewable energy sources for domestic and commercial use. So that is the main application of thermodynamics. So, sa thermodynamics class, yun yung pinaka main application. But also, we have this in our households, the refrigerators, and air cons. So, yun yung kadalasan nagagamit natin sa bahay. But, unconsciously, itong electricity natin, saan ito nagmumula? So, that came from power plants wherein the power plants transmit it to the WESM and the WESM contribute it. So, maririnig nyo na yung WESM. So, the WESM is the distributor of the electricity. Okay. Meron din doon na stock market. Okay. So, kaya na-distribute na to the different electric cooperatives. Okay? So, madami pang applications. I will not elaborate it. Okay? So, here in thermodynamics, may tinatawag tayong macroscopic and microscopic analysis. What are those? The first one is the statistical thermodynamics and the classical thermodynamics. Excuse me? Anong pinagkaiba ng dalawa? We have, in the statistical thermodynamics, that is a more elaborate approach wherein that is based on the average behavior of large group of individual particles. So, when it comes to statistical thermodynamics, tinatawag din siyang microscopic. Kasi nga, sabi ko, behavior of large group of individual particles. So, dito, nag-look into every molecule tayo and analyze collective molecular action by statistical methods. While in classical thermodynamics, sabi ko nga, macroscopic approach na to, hindi siya nagre-require ng knowledge of the behavior of individual particles. So, so ang statistical, ulitin ko lang microscopic, while classical is macroscopic. So we concern ourselves with the overall effect of the individual molecular interaction. So it provides a direct and easy way to the solution of engineering problems. Okay, so here in our subjects, the classical thermodynamics is more likely implied or used. Okay, so what is the basic concept of thermodynamics? So here you can see is the image wherein there is a system that is separated from the surroundings and by the system boundary. So tatlo yung class. The basic concept, ulitin ko lang, we have the system that is separated from the surroundings. Okay, wait. Okay, so makikita nyo class. Eto. So you see this is the system. So separated siya. So, ang system natin separated from the surroundings. And this system, separated siya ng tinatawag nating boundary. Okay? Okay. Wait lang. Okay. So, this is now the basic concept of thermodynamics. So, ulitin ko lang. May tinatawag tayo tatlo to, system, boundary, and the surrounding. So, the system is separated from the surroundings by the so-called system, boundary. Wait, excuse me. Wait. So, ano nga ba yung system or tinatawag nating thermodynamic system? So, it is defined to be fixed, okay? To be a fixed mass that occupies a space, okay? A space that may or may not be changing in volume or shape. Yan yung system, ah. So, balikan nyo, this is your system. Fixed mass siya. So, that is also defined as a quantity of matter or region in a space upon which attention is concentrated in the analysis of a problem. Okay? So, ano naman yung surroundings? Sabi ko nga, the system is separated from the surroundings by the boundary. So, what is the surroundings? So, the other word for that is the environment. So, it includes everything external to the system. It includes also the mass or region outside the system. Sabi ko nga, the system is separated from the boundary, from the surroundings by the boundary. So, ano nga ba yung boundary? So, that is the real or imaginary surface that separates the system from its surroundings. The boundary of the system can be fixed or movable, okay? And the boundary is the contact surface by both the system and the surroundings. So, mathematically speaking, the boundary has zero thickness. Thus, it can neither contain any mass nor occupy a space, any volume in. Neither contain any mass or nor any volume in space. Okay? So, balikan natin, the system is separated from the surroundings by the boundary. Tatlo yung klasa. System separated by the system is separated from the surroundings by the boundary. Okay. So what are the three classes of systems? So whether mass siya, fixed mass siya, or fixed volume space. So these three system, bakit hinahatag to? Because some of the thermodynamic problems are solved depending upon the system elaborated and the problem. Okay, the first one is the closed system, second is the open system, and the third is the isolated system. So first, what is the closed system? So alam din to na controlled mass kadalasan. Okay, so fix yung mass niya, makikita niyo dito. We have energy in and energy out. So, energy lang Walang mass transfer across the system boundary. Sabi ko nga, itong tatlo, tatandaan nyo to. The system, the surroundings, and the boundary. So, a system of a fixed mass. So, given na sa'yo, fixed yung mass mo dito. There is no mass transfer as well as there may be energy transfer into in or out of the system. Sabi ko nga, and the volume of the closed system does not have to be fixed. Okay? Yun lang sa energy in, energy out in a closed system. Controlled mass ang tawag doon. So, what is the basic example here? A certain quantity of fluid on a cylinder bounded by piston continuous a closed system. Okay, in your combustion engineering, you will see a piston cylinder. So, piston siya klasa. Yung mga hindi maka-imagine yung piston. That is a closed cylinder wherein may cycle din siya. So, when it push downward, so, yung fluid doon, andun lang. Okay? So, ang boundary doon is yung piston cylinder mo. System doon sa loob na fluid surrounding yung sa labas, which is the air. Okay. Another example is the open system or yung control volume natin. So, closed system is a controlled mass while open system is a controlled volume. So, ano nga ba dito? So, matter crosses the boundary of the system. So, energy transfer is also present, may or may not be present. So, both, kung kanina energy lang, ito, both mass and energy can cross the boundary of the control volume. Okay? And the control volume can be fixed in size and shape. Okay? So, what is the example? So, a large number of engineering problems involve mass flow of the system. Therefore, are modeled as control volume. So the boundaries of a control volume are called control surface. So they can be real or imaginary. So what are those? Example of this, engineering devices that generally open system. So air compressor, energy in, energy out, mass in, mass out. Okay? So sa air compressor ka, sabi nga dito, air enters at low pressure and leaves at high pressure. So, meron tayong energy transfer across the system boundary as well as yung mass mo andun ba. Okay? Mass in, mass out. While the third classification of system, sabi ko nga, open, control mass, closed, control volume, we have the third one, the isolated system. So, in an isolated system, there is literally no interaction. Okay? No interaction between the system and the surroundings. Okay? Walang interaction dyan. Fix yung mass mo and as well as yung energy sa loob lang class. There is no mass or energy transfer across the system boundary. Okay? So, tatlo yun. Sana maalam. If we have that classification of system, now we will move on to the properties of the system. So what are the basic? Sabi dito, any characteristic of a system is called a property. So the property of the system is a characteristic quality that the entire system and depends on not how the system changes state, but only on the final system state. Okay? So hindi siya doon sa system change, sabi nga dito, but on the final system state. Property siya. So what are the familiar properties of the system? So kadalasan, ito yung sinusolve natin dito sa thermodynamics. The pressure, the temperature, the volume, and the mass. So thermodynamic properties are divided into two general types. The first one is the intensive property and the second one is the extensive property. So what is the difference between these two properties? In intensive property class, one that does not depend on the mass of the system. So, independent siya sa size ng system. Ang pinaka-example ng intensive property natin is the temperature and the pressure. So, walang mass na involved dito. Okay? Yan yung first example. While in an extensive property, eto naman class, nagde-depend siya sa mass of the system. So, nagde-depend siya sa size or the extent of the system. So, we have the mass, volume, momentum, kinetic energy as example. Because volume natin, minsan nakukuha natin siya sa density is equal to mass over volume. So, volume is equal to the mass over the density. Momentum natin, also, needed din yung mass natin. As well, the kinetic energy, which is 1/2 mv squared. Mass times the velocity squared. Okay? So, dependent siya, extensive property siya. If we have, elaborate ko lang, balikan ko. yung basic concept, we have the system, boundary, and the surroundings. The three classifications, we have the open, the closed, and the isolated system. We have also the properties of the system. Ano nga ba yan? The two, the extensive and the intensive. And we have also the state of the system. So, in the state of the system class, all properties can be measured or calculated through the entire system, which give us a set of properties that completely describes the conditions or the state of the system. Okay? So, ang system natin, hindi siya nag-undergo ng any change. So, thermodynamics deals with equilibrium states. Okay, hindi lang yung one process, but each states. Excuse me. So, each states yan, class. Kasi, in cycles, in problem thermodynamic cycles, we need to compute each in point 1, state 1, anong mga andun? We have the pressure, temperature, mass, and volume. Okay. And also, the very basic, very important is the equilibrium. Ano nga ba class ang equilibrium? So, in equilibrium class, it implies a state of balance. Also in your life, you need a state of balance. Okay? So, a system in equilibrium experiences no changes when it is isolated from its surroundings. Okay. So, these are the different types of equilibrium in thermodynamics. The first one is thermal equilibrium, wherein it involves no temperature difference or differential. Okay? Ibig sabihin, kung ano yung temperature niya at point 1, yun din yung temperature niya at point 2. Okay? Same throughout the entire system. Okay? Thermal equilibrium. While mechanical equilibrium, if the pressure at any point of the system with time has no change, the system is in mechanical equilibrium. Okay? So kung thermal temperature has no change, while mechanical equilibrium, pressure at any point has no, with regards to time, has no change. And we have also phase equilibrium. If a system involves two phases, it is in phase equilibrium. So the mass of each phase reaches an equilibrium level and stays there. Okay? So involves two phases. Pag na-reach na nila yung equilibrium level, stay pa rin siya doon. And the chemical equilibrium, wherein the chemical composition does not change with time. Okay? So no chemical reaction occurs. So the system is in a chemical equilibrium. Okay. So ulitin ko lang yung apat ng equilibrium. We have the thermal. The first one is the thermal. The second is the mechanical equilibrium. So pressure dito sa thermal, the temperature. The third is the phase, so two phases. Walang pinagbago, na-reach na nila yung equilibrium level. So phase equilibrium, and the fourth one is the chemical equilibrium we're in. Sabi ko nga, chemical composition does not change with that. Okay? So, kanina nakita natin yung properties and state ng thermodynamics. So, here naman, we will proceed to the process of thermodynamics. Sabi nga dito, any change that the system undergoes from one equilibrium state to another is called a process. Okay? The series of states through which a system passes through during its process is called path of the process. Okay? Sabi nga, proseso yan. A change in the system, so nag-change siya. Process na yun, tawag doon. Okay? So, when the system changes from one equilibrium state to another, so tawag doon process, the path of the successive states through which the system passes. Okay? Proseso yan, class. one equilibrium state. Halimbawa, thermal equilibrium, sunod, mechanical equilibrium. So, process na yun. If we have the process path, the process, meron din tayong tinatawag na process path. So, that is, from the figure, we have property A, property B. From state 1 to state 2, that is described. So, connected yan from state 1 to state 2. Okay? So, ang tawag dyan is process path. So, describes infinite number of system that occurs when a system undergoes particular process from state 1 to state 2. Okay? So, process path yun. Bakit kailangan natin yun na process path? Kasi papasok na tayo sa thermodynamic cycles. Because a thermodynamic cycle is a collection of two or more processes for which the initial and the final state are at the same. So, connected na yun ang process path natin. Therefore, thermodynamic cycle na siya. So, kung meron tayong different equilibrium kanina, that are from one state lang to two state. Then the next topic naman is the metastable equilibrium, wherein involved na dito yung processes, buong system na or buong cycle na. Okay? So another one, equilibrium. So metastable equilibrium. So if a system would undergo a large change in its properties. So properties, extensive man siya or intensive or extensive man siya. When it is subjected to small disturbance, ang tawag doon ay metastable equilibrium. The second one naman, class, is the quasiequilibrium, wherein the first in the passing from one to the next, the deviation from equilibrium is small and thus negligible. A quasi-equilibrium process occurs. In this case, each state in the process can be idealized as an equilibrium state. Kung ang deviation, class, is so small, kadalasan negligible siya, tinatawag siyang quasi-equilibrium. Okay? Ulitin natin sa metastable, disturbance to, class. Dito, deviation natin ng equilibrium, small, negligible siya, quasi-equilibrium. And last but not the least is the non-equilibrium, wherein system, however, goes from one equilibrium state to another through a series of non-equilibrium state. So, parang combustion siya, class. So, a non-equilibrium process, of course. Take note from the figure, you can see, makikita nyo that from point 1 to point 2, connected siya. May nangyaring equilibrium, minimal lang yan, class. So, tawag doon is quasi-equilibrium. But from the second one, you can see that is a dotted path from point 1 to point 2. Ibig sabihin, may series of non-equilibrium state dyan. Makikita nyo, paliit ng paliit. So, that is non-equilibrium process. Okay? So, ulitin ko lang yung sa system na metastable, quasi-equilibrium, non-equilibrium. So, ano nga ba ang perfect iso sa thermodynamics? Okay. So, the perfect iso is often used to designate a process for which a particular property remains constant. So, here are the processes wherein you should know or should bear in mind that this is our important processes here in thermodynamics. Okay, the first one is the isothermal process, the isobaric, the isometric, or isochoric processes. When we say isothermal, class, isothermal process, when we say isothermal processes, makikita nyo dyan that the process during which the temperature T remains constant. Isothermal, the temperature is constant. Isobaric, pressure remains constant. Isochoric or isometric, that is the specific volume remains constant. Why? Because in using thermodynamics, in using steam tables, you should know these processes. Or in the next few lessons, we need to understand this because we need to derive the different formula used in the ideal gas. Okay? So here is a hint also, the steady flow process. So kadalasan din to nakikita sa problem solving in thermodynamics, wherein steady implies no change with time. Okay? So steady ka lang. Okay, so anong opposite ng steady? We have unsteady or transient. Kung steady flow process yan, anong steady flow? Kadalasan uniform siya, implies no change with location over a specified region. So, may mga processes tayo which fluid flows through a controlled volume steadily. Okay? So, ano nga ba ang steady flow processes? Kadalasan class, nakikita to sa engineering devices class that operate for a long periods of time under the same condition. So, ano nga ba to? Kadalasan class, turbina, steady flow yun class. Because, you know, the turning of the blades of the turbine can generate electricity. So, kadalasan andun, steam ang pumapasok or mga tubig sa mga turbina. So, uniform, steady yung process niya. Well, pumps, ito nakikita nyo sa mga bahay nyo if you have water pumps. Okay. From point 1, from the ground to your faucets. So, to the tank, and to your faucet. So, steady flow yung processes natin doon. Okay? And also in thermodynamics, may boilers and condensers tayo. Okay? The fluid properties can change from one point to another within the control volume, but any fixed point, they remain the same during the entire process. Okay. So that's all for our first session or the first topic here in thermodynamics. The next one is dimension, temperature and temperature scale, and pressure measuring device. So stay tuned for our next topic. Okay, so computation na yun class. So this is just the basic. Wrap up ko lang. Ulitin natin. We have elaborated the history of thermodynamics. Ano nga ba nangyari doon? So, basahin nyo lang class. But ano yung pinaka is father of thermodynamics, si Nicholas Leonard Sadi Carnot. Kasi siya na yung nag-develop ng Carnot cycle, Carnot engine, Carnot theorem. After that, if we have the history, ano yung sunod class? We have now the basic concepts sa thermodynamics. What are those? So we have the system. The different application pala muna class. Yung application ng thermodynamics wherein nakikita nyo, sabi ko, ang main application niya is yung nakikita natin sa bahay. Various power plants. From power plants, that the electricity was generated, passed through the WSM, and after that, transmitted to the different cooperatives. So we have now electricity, thermodynamics, and class. Also, there are different air conditioning, the motors, the vehicles that we use to ride. Okay. So that are the different application of thermodynamics. And after that, the basic concepts were in the system, the surrounding, the boundary. Sabi ko, the system is separated from the surroundings by a system boundary. After that, may tatlong system tayo. The closed, the open, and the isolated system. So alam niyo ng pinagkaiba nun sa closed and the open system. And after that, different processes, the metastable, the different equilibrium that occur. We have the mechanical equilibrium, thermal phase equilibrium, and chemical equilibrium, and also the different the properties of the system, the intensive and the extensive properties. And after that, we have discussed also the different properties. And we have now the system, the state, the system state, the properties of the system, the processes of the system, thermodynamic cycles, the prefix iso, for isothermal, isochoric, isometric. So those are the, pag sinabi natin yun, constant yung isang bagay yun doon, temperature, pressure, or specific volume, as well as the processes nga ng system natin, or process path, yung na-discuss natin, the metastable, the non-equilibrium, the quasiequilibrium. Okay? So, yung last topic natin is yung yung steady flow. So, thank you and God bless. So, stay tuned for our next topic.